the third quantity that we need to describe motion, which is acceleration. Again, we think of average acceleration and instantaneous acceleration. The difference is the elapsed period of time. So for the average acceleration, you need the velocity at the initial point, you need the velocity at the final point, then you need the difference, the change in the velocity and the change in the time. You divide the change in velocity by the change in time, you get the average acceleration. Again, if you are talking about distinct values for time and for velocities, that's to say separated well, not slight change in time, it would be average value. If it is slight change, it would be instantaneous acceleration. The unit for the acceleration is a unit of velocity, which is meter per second, divided by a unit of time. So meter per second becomes meter per second squared. This is the unit for acceleration in the SI system. For example, if the final velocity was 20 meter per second, the initial velocity was 10 meter per second, they are both along the same direction, and the elapsed time is 2 seconds, then the acceleration is 20 minus 10 divided by 2, which is 5 meter per second squared. So if the velocity and acceleration are in the same direction, the velocity and acceleration in the same direction, the speed increases with time. But if they are in opposite directions, the speed decreases with time. Okay? So if the initial velocity was minus 10 meter per second, the final minus 20 meter per second, the change in time 2 seconds. We apply again V final minus V initial, and we end up with minus 5 meter per second squared. It's in the opposite direction. The minus sign is just to tell us that this is in the opposite direction. Check your understanding. A car must always have an acceleration in the same direction as its velocity. True or false? What do you say?
False.
Yes.
False.
Yes, thank you. Yes, yes, I like that. So we all understand this game. Acceleration, we need it in order to speed up. We also need it to speed down. If we want to speed up, it would be along the same direction as the original speed. If we want to speed down, it would be opposite direction to the original speed. So it can be in either direction. It is possible for a slowing car to have a positive acceleration. What would you say?
Yes.
Yes, it is false. Slowing down, no way to slow down if the acceleration was the same direction as the velocity. It has to be opposite. An object with constant non-zero acceleration can never stop and remain at rest. True or false? So it has constant non-zero acceleration.
False. Wait.
No, be careful. Can never stop and remain at rest.
True.
Because it is non-zero. The acceleration non-zero. What is acceleration? Acceleration is change in velocity. So the velocity is changing, and the change is not zero. This means the velocity will always have some value. So it will be moving, whether to the right or to the left, we don't care. It will always be in motion. It never be at rest. Okay? So this is true. Very well. Like we did for instantaneous velocity, we also calculate the instantaneous acceleration. It is the limit when delta t is so small, then the average acceleration becomes instantaneous acceleration. The same unit like the average acceleration, it is meter per second squared. And the way to get it, we get it graphically as the tangent of the curve for the velocity versus time. We get it at the specific time of interest. Okay. So here you have this car. This is the initial velocity. This is the final velocity. This is the initial time. That is the final time. Okay. So we can calculate the average acceleration, V final minus V initial, divided by T final minus T initial. That's the average acceleration. For the instantaneous acceleration, we need the slope. So at point Q, you have this line. You need the slope of this line. Okay. This will give you the instantaneous acceleration. The slope here of the tangent. This will give us the instantaneous acceleration. Okay. While the blue line here, this is for the average acceleration because it deals with initial and final values, distinct points, distinct times. Okay. So this is average acceleration. The slope of the blue line is the average acceleration. So you take delta V, the change in the velocity, divided by delta T, the change in time, you will get the average acceleration for this motion. So now we understand the difference between instantaneous and average acceleration. Always for instantaneous, you are interested in one point and you take the slope at that point, while for average, you have two distinct points and you are interested in the difference, delta or delta T. Check your understanding. A, B, C, D, E, F. We have these graphs. Parts A, B, and C of the figure below represent three graphs of the velocities of different objects moving in straight line as functions of time. The possible accelerations of each object as a function of time are shown in parts D, E, and F. These are the possible accelerations. Match every velocity versus time graph with the acceleration versus time graph that best describes the motion. Okay. So here, what do you have? You have a linear change, the velocity change with time linearly. Another way, it is with constant positive acceleration. Constant positive acceleration. Check these three. Which one has constant positive acceleration?
E.
E. Thank you. Yes. So E, this is constant positive acceleration. So we have this curve for the velocity. Now for this one, the velocity is changing with time. Okay, it is changing with time. So and it is positive still. So the acceleration need to be changing with time. Although we said that the kinematics equation that we have earlier requires constant acceleration, put this aside, but just compare the behavior of these graphs. If the velocity changes according to this path, then the acceleration needs to be changing linearly this way. The third graph, if this is the velocity changes, this would be the acceleration. So here, this is linear increase, means the acceleration is constant and is positive for this segment. Then here there is no change in velocity, means the acceleration is 0. If there is no change in the velocity, the acceleration is 0.